Bismillahirrahmanirrahim. Today we are going to start lecture number 13. This is part 3 of our topic mensuration. In first and second parts we discussed 2D and 3D shapes with their important formulas. Now we are going to solve the past papers by using a knowledge which we have developed in lecture number 11 and 12. Our first problem is October-November 2004, paper 1, question number 7. A block of wood is a cuboid 10 cm by 6 cm by 2 cm. Find part A, its volume, part B, its surface area. We know volume of cuboid is length into breadth into height, that is L into B into H. Here in figure, length L is equal to 10, breadth B is equal to 6 and height H is equal to 2. So putting these values, it is equal to 10 into 6 into 2. This is equal to 10 multiplied by 6 is equal to 60 multiplied by 2. This is equal to 120 centimeter cube. Now surface area of cuboid is equal to, as we can see the slide of formulas we discussed in lecture number 12, in which the surface area of cuboid is equal to 2 bracket L into B plus 2 bracket B into H plus 2 bracket L into H. So over here surface area of cuboid is equal to 2 bracket L into B plus 2 bracket L into H plus 2 bracket B into H. This is equal to 2 bracket 10 into 6 plus 2 bracket 10 into 2 plus 2 bracket 6 into 2. 10 multiplied by 6 is equal to 60. 10 multiplied by 2 is equal to 20 and 6 multiplied by 2 is equal to 12. So this is equal to 60 multiplied by 2 is equal to 120 plus 2 multiplied by 20 is equal to 40 plus 2 multiplied by 12 is equal to 24. This is equal to surface area equal to 184 centimeter square. So this is our answer. Next question is May-June 2004, paper 1, question number 18. The base of a pyramid is a square with diagonals of length 6 cm. The base is a square as shown in figure. Two diagonals of length 6 cm each are equal, as we know from our previous knowledge in lecture 10. A square is shown in which its diagonal D1 and D2 are equal. Now the half of diagonal is equal to 3 cm as shown. The sloping faces are isosceles. It means that two sides of triangles are equal as shown. So both the sides are 7 cm each. The height of the pyramid is under root L centimeter. We can draw the height in the given pyramid as shown is equal to under root L. The height is shown is equal to under root L. Diagonals D1 and D2 are also shown in next clear figure. The length of half diagonal is equal to 3 cm as shown. The sloping length of triangle is 7 cm as shown. Now in order to understand the concept, we can see the actual pyramid in the video clip. The pencil in the center of the pyramid is shown as the height of the pyramid, which convert two-dimensional shape in 3 dimensions as shown. When we open the pyramid, the height can be shown by the pencil. Sloping length of triangle can also be seen by the index finger. The diagonal can be seen by the dotted line. The right angle triangle having vertices A, O and B can also be seen in order to understand the pyramid. Here the triangle AOB easily fit into the actual diagram of pyramid as shown. So this is a required triangle to work on it for solving our problem. Now back to our question. Triangle AOB is redrawn as shown, having height is equal to under root L, base is equal to 3 and sloping length is equal to 7 centimeter. Now using Pythagoras theorem, 7 whole square is equal to 3 whole square plus under root L whole square. So this is equal to 49 is equal to 9 plus L. So this implies that L is equal to 49 minus 9 is equal to 40. So L is equal to 40 is our answer. Next question is May-June 2005, paper 1, question number 18. OAB is a sector of a circle with center O and radius 8 cm. Angle AOB is equal to x degree. Part A, write down an expression in terms of x and pi for the area of the sector OAB. We can see the slide of lecture number 10, Mensuration Part 1. For sector, area of sector is given by theta upon 360 multiplied by pi r square. If theta is the angle as shown, now we apply this formula in the given problem. Area of sector is equal to theta upon 360 multiplied by pi r square. Here theta is equal to x degree and r is equal to 8. So putting these values in the formula, area of sector is equal to x upon 360 multiplied by pi into 8 whole square. This is equal to x pi into 64 upon 360. Now cancel out 64 by 360. We get area of sector OAB is equal to 8 pi x upon 45 is the answer of part A. Now part B, PQR is a semicircle as shown having radius 4 cm. So R is equal to 4. The area of the sector OAB is 1 upon 3 of the area of this semicircle. 8 pi x upon 45 is equal to 1 upon 3. Area of semicircle is equal to pi r square upon 2. So 1 upon 3 bracket pi bracket 4 whole square upon 2. This implies that 8 pi x upon 45 is equal to 1 upon 3 into 16 pi upon 2. Now cancelling out 2 and 16, we get 8. Pi cancel out, 8 and 8 cancelled out. So we get x is equal to 45 upon 3. This implies that x is equal to 15 degree is our answer. Next question is May-June 2005, paper 1, question number 19. ABCE is a pyramid. A, B, C, D and E is a pyramid shown in figure. The base BCDE is a square of side 10 cm as shown. The sloping faces are isosceles triangles. AB is equal to AC is equal to AD is equal to AE is equal to 13 as shown in figure. Part A, calculate the area of sloping face ABC. Triangle ABC is redrawn for you having base is equal to 10 and sloping side is equal to 13 as shown. Now area of sloping face is equal to area of triangle ABC. This is equal to 1 upon 2 base B into height h. Here B is equal to 10. We can draw perpendicular bisector as the height h as shown, making angle of 90 degree on the base B. The half of base is equal to 5 cm as shown. The vertices of triangle is ABC and the bisecting point is let to be x as shown. So in triangle ABX, using Pythagoras theorem, 13 whole square is equal to 5 whole square plus h square. 169 is equal to 25 plus h square. H square is equal to 169 minus 25. Subtracting 25 from 169 we get 144. Therefore h square is equal to 144. Taking square root both sides we get h is equal to 12 centimeter. Therefore area of triangle ABC is equal to 1 upon 2 into base is equal to 10 multiplied by h is equal to 12. Cancelling out 10 by 2 we get 5. So 5 multiplied by 12 is equal to 60 centimeter square. So answer of part A is 60 centimeter square. Now part B, the pyramid ABCDE is joined to an identical pyramid BCDEF to form ABCDEF. Calculate the surface area of solid ABCDEF. The solid ABCDEF is shown by shading it. We know that square pyramid ABCDE contains 4 triangles because base is square. Since ABCDEF are two identical pyramids, so they have 8 triangles. Therefore, surface area of solid ABCDEF is equal to surface area of 8 triangles. This is equal to 8 bracket 60 centimeter square, which we have already found. This is equal to 480 centimeter square. So this is our answer. Next question is October-November 2002, paper 1, question number 24. A rectangular piece of card measures 20 centimeter by 14 centimeter as shown. Square of side x centimeter are cut from the 4 corners and the card is folded to make a box. This is x and this square is also x. So the remaining length of the box will be 20 minus x minus x. This box on the top left is also x. So the remaining width will be 14 minus x minus x. Part A. Show that the volume V of the box is given by V is equal to 4x bracket 10 minus x bracket 7 minus x. Now the length of the box is equal to 20 minus x is equal to 20 minus 2x. Its height is x as shown. Its width is equal to 14 minus 2x. So volume is equal to length L multiplied by width W multiplied by height h. This is equal to 20 minus 2x bracket 14 minus 2x multiplied by x. So arranging it, x is written first, then bracket, take 2 as common, so 2 bracket 10 minus x. Again take 2 common, so we get 2 bracket 7 minus x. This is equal to multiplying 2 and 2 is equal to 4. This is equal to 4x bracket 10 minus x bracket 7 minus x. So it is shown. Part B. You are asked to find the value of x which will produce the greatest value of box. Here we have found volume is equal to V is equal to 4x bracket 10 minus x bracket 7 minus x. For x is equal to 0, the volume is equal to 0. For x is equal to 1, V is equal to 4 bracket 10 minus 1 bracket 7 minus 1. This is equal to 4 multiplied by 9 multiplied by 6. 6 multiplied by 9 is equal to 54. Multiplied by 4 is equal to 216. So volume is equal to 216. For x is equal to 2, V is equal to 4 multiplied by 2 bracket 10 minus 2 bracket 7 minus 2. This is equal to 8 bracket 8 bracket 5. This is equal to 8 multiplied by 40 is equal to 320. So V is equal to 320. For x is equal to 3, 4 multiplied by 3, 10 minus 3, 7 minus 3 is equal to 12 multiplied by 7 multiplied by 4. This is equal to 12 multiplied by 7 is equal to 84. Multiplied by 4 is equal to 336. We proceed until the value of V goes up and then goes down to find the peak value. So for x is equal to 4, we have 4 multiplied by 4 bracket 10 minus 4 bracket 7 minus 4. This is equal to 16 multiplied by 6 is equal to 96 multiplied by 3 we get 288. So V is equal to 288. So the value goes up and then goes down. Now plotting the values of V on graph paper against the value of x. The big box on vertical axis can be taken as 100. Second box is equal to 200. Third box is on 300. First point is O, that is 0. For x is equal to 0, V is equal to 0. Second point, for x is equal to 1, V is equal to 216 as shown. Third point, for x is equal to 2, V is equal to 320 as shown. Fourth point, for x is equal to 3, V is equal to 336 is plotted as shown. Fifth point, for x is equal to 4, V is equal to 288 plotted as shown. Now connecting all points with a smooth sketch making a smooth curve on top as shown. Now for peak value of V, the corresponding value of x on x-axis is equal to 2.6. So the value of x is equal to 2.6. So this is the maximum value of V. So this is our answer. Next question is May-June 2003 paper 2 question number 7. In this question, value of pi is given. Formula of surface area of a sphere is 4 pi r square is given. And volume of a sphere is 4 upon 3 pi r cube is also given. The question says that a closed container shown in figure is made by joining together a cylinder of radius 9 cm and a hemisphere of radius 9 cm as shown in diagram 1. The length of cylinder is 18 cm denoted by L or H, whatever. The container rests on a horizontal surface is shown which is exactly half full of water. Calculate the surface area of the inside of the container that is in contact with the water. The answer is incorrect to the nearest square centimeter. The surface area inside container in contact with the water. Here the first portion of container is a half circle as shown, and its surface area is equal to 1 upon 2 pi r square. The second portion is half cylinder open from both ends. Therefore, the surface area is equal to 2 pi r h divided by 2 because of half cylinder. Third portion is half hemisphere. Here a hemisphere is shown blue in color, in which half of hemisphere is shaded. The water is actually in contact with half of half hemisphere, that is quarter of hemisphere shown in yellow portion, and it's also shown in the shaded portion of hemisphere. The surface area is equal to 1 upon 4 due to quarter bracket. The surface area of a sphere is equal to 4 pi r square is equal to pi r square. Therefore, surface area inside container is equal to first portion plus second portion plus third portion of surface areas. It is equal to 1 upon 2 pi r square plus 2 pi r h upon 2 plus pi r square. This is equal to 1 upon 2 bracket 3.142 bracket 9 whole square plus 2 and 2 cancel out. We get 3.142. R is equal to 9, H is equal to 18 plus 3.142 bracket R is equal to 9 whole square. This is equal to 9 whole square multiplied by 3.142 is equal to 254.502 divided by 2. We get 127.251. This is equal to 127.251 plus 3.142 multiplied by 9. We get 28.278 multiplied by 18. We get then multiplied by 18 we get 509.004 plus 509.004 plus 3.142 multiplied by 9 we get 254.502. We write 254.502. Now adding these values 127.251 plus 509.004 plus 254.502, we get 890.757. Therefore, surface area of inside container is equal to 890.75 centimeters square. So rounding off to the nearest square centimeter, we get 891 centimeters square is our answer. Now part B. Show that volume of water is equal to 972 pi centimeter cube. Here portion 1 is volume of half cylinder, portion 2 is volume of half hemisphere. It means that volume of quarter is fair. Therefore, volume of half cylinder is equal to pi r square h upon 2. Pi bracket 9 whole square bracket 18 divided by 2 is equal to 9 whole square is equal to 81 multiplied by 18 is equal to 1458 divided by 2. We get 729 is equal to 729 pi. Volume of half hemisphere is equal to volume of quarter hemisphere is equal to 1 upon 4 bracket 4 upon 3 pi r cube. 4 and 4 cancel out. We get pi bracket 9 whole cube divided by 3 is equal to 729. Divided by 3 we get 243. This is equal to 243 pi. Therefore, volume of water is equal to, adding two values, is equal to 729 pi plus 243 pi. We get 972 pi. It is shown as per requirement. Part C. Part C. The container is held with its axis vertical as shown, the hemisphere being at the bottom as shown. Calculate the depth of water. What is the depth of water? Here in figure, let D is equal to depth of water. Here R is the radius of hemisphere and R is also the depth of water contained in hemisphere is equal to 9 cm. Let H is equal to height of cylinder. Volume of water is equal to 972 pi as we have shown. Equal to volume of cylinder having water plus volume of hemisphere is equal to pi r square h plus 1 upon 2. 4 upon 3 pi r cube is equal to 972 pi. Pi bracket 9 whole square h 2 upon 3 pi bracket 9 whole cube is equal to 972 pi. Pi bracket 81 h plus 9 into 9 into 9 divided by 3 multiplied by 2 we get 486. Taken pi as common is equal to 972 pi. Here pi and pi cancelled out. 81h is equal to 972 minus 486. H is equal to 972 minus 486. We get 486 divided by 81. We get 6 centimeter. So height of cylinder is equal to H is equal to 6 centimeter. Therefore D is equal to R plus H. This is equal to 9 plus 6. So D is equal to 15 centimeter. Therefore depth of water is equal to 15 centimeter. Part D. The container is now placed with its circular end on a horizontal surface as shown in diagram 3. Find the depth of the water. Here D is depth of water. This is a cylinder. The volume of cylinder is equal to volume of water, and volume of cylinder is equal to pi r square h is equal to volume of water which we have found in previous part, that this is equal to 972 pi. Here pi and pi cancelled out. R is the radius of cylinder is equal to 9. Therefore 9 whole square multiplied by h is equal to 972. H is equal to 972 divided by 81. H is equal to 972 divided by 81 is equal to 12. Therefore H is equal to 12 centimeter is our answer, which is the depth of water. So this is the end of lecture number 13 and part 3 of mensuration, in which we have solved past papers related to our topic mensuration. So if you have any question, then please ask me in the comment section. I will respond it. Thank you very much. Allah Hafiz.